Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're continuing our look at advanced stoichiometry. So the problems we looked at last are stoichiometry. We're going to apply different things. We already did the gas laws with them. So today we're going to take that value of stoichiometry and we're going to apply with it excess reactant. Now, excess reactant has to do with limiting a reactant. Remember we talked before, if I have both the reactants, the one that produces a smaller amount, that reactant is a limiting reactant. That's when it shuts down the reaction when it runs out. Excess reactant then is a reactant that remains after the reactant is done. So how much is hanging out, unreacted, that's what we're going to find out today. So let's take a look at a problem. So we're going to determine that amount. So we're going to determine the amount of silver oxide formed, as well as the amount of excess reactant that remains when 83.45 grams of silver react with 20.35 liters of oxygen STP. We're not going to do the combined gas law thing here. We'll just keep it nice and simple. All right, I could do both. Make it quite interesting, wouldn't it? All right, so we'll make a very simple reaction. We got silver and oxygen. That's a synthesis reaction. And when we do that, we're going to slam them together. Oxidation number, silver is 1 plus, oxygen is 2 minus. Swap them down. We get Ag2O, balance it up. Put a 4 and an 8, 4 for silver and 2 for silver oxide. All right, now we'll take our first reactant. Silver, 83.45 grams of silver. And remember, that's in grams, so molar mass. We're going to go for atomic mass. Number of grams in a mole is 108 grams, whole numbers for 1 mole. We're going to take silver and silver oxide, because that's what we're looking for. That molar relationship is 4 to 2. So 2 moles of silver oxide is 4 moles of silver. Now we're going to need to determine the amount. That's going to be mass. We're going to do silver 108 times 2 is 216. Oxygen 16. 16 plus 216 is 232 grams. Take 83.45 times 2 times 232 equal, divide by 108, equal, divide by 4, equal, and yes, you could divide that through and make it easier if you want to. All right, when we multiply those all through, we get 89.63 grams of silver oxide. Now, is that my answer? I don't know. It could be. We got to do the other one to find out. So we're going to take the 20.35 liters of oxygen. All right, now that's volume, and we are at STP. So we're going to do 1 mole is oxygen is 22.4, and we're looking at oxygen and silver oxide. So that's 1 to 2. So 2 moles of silver oxide over 1 mole of oxygen. That should be O2 there. I apologize. And then again, the same mass, 232 grams of silver oxide over 1 mole. Take 20.35 times 2 times 232 equal, divide by 22.4 equal. For sig figs, we're going to get 421.5. So which one's correct? Well, we get that smaller amount. That's it. The reaction shuts down. So that means that 421.5 can happen. So 89.63. So my silver is my limiting reactant. My oxygen is my excess reactant. Now, how much oxygen is excess? So what we're going to do is we're going to take that silver and we're going to go to that oxygen. See how much oxygen was used up. So we're going to get rid of that what we've looked at so far. 1 mole of silver is 108 grams. And when we say the molar relationship between silver and oxygen is 4 to 1. So therefore, 1 mole of oxygen is 4 moles of silver. And then with the molar volume, 22.4 liters is 1 mole. Take your calculator, 83.45 times 22.4 equal, divide by 108, equal, divide by 4. Now there's a check here. The number here is 20.35. When you multiply this through, it should be less than 20.35. If it's not, something wrong took place. So let's multiply them through. And we get 4.327 for 4 sig figs. That is definitely less. So we're going to take the original amount, 20.35, and we're going to subtract 4.327. Last fill column, subtraction. We're going to get an answer of 16.02 liters of oxygen, and that's the amount of excess oxygen that we have. All right, awesome. All right, let's try another one. Identify the amount of calcium nitrate formed as well as the amount of excess reactant remaining when 33.88 grams of calcium chloride react with 100.22 grams of silver nitrate. All right. Now, the reaction calcium chloride, 2 plus, and minus for chlorine, silver plus one plus and minus, so they equal out. This is double replacement. Calcium, the cation is going to go with the anion. The anion is nitrate, so we're going to generate silver chloride and calcium nitrate, balancing it up. I'm going to put 2 in for silver nitrate and 2 in for silver chloride. All right, so for the first reaction, where 111 grams of calcium chloride is 1 mole, and then we're going to do calcium chloride to calcium nitrate, that's 1-to-1, and then calcium's 40, nitrogen 14 times 2, 28, 16 times 3 is 16 times 6 is 96, 96, 28, and 40 is 164. Multiplying through, we get 50.06 grams. Could be the answer. We don't know. So we take the other one. Oops, I got to come over here, don't I? There we go. So we take 100.22, and then silver's 108, nitrogen is 14, oxygen 3 times 16, 48. So 170 grams is 1 mole of silver nitrate. Look at the relationship, 2-to-1. So therefore, that value is the same. We multiply through 5 sig figs. We get 48.341, which is the least number. That's not 48. That 50 isn't there. So we're going to take, that means silver nitrate's my limiting reactant. We're going to go to the calcium chloride, which is my excess reactant. So therefore, we have that being like this. And when we multiply that through, 32.719, which is less than the 33.88. So it is correct. When we subtract that, last fill column, we get 1.16 grams of calcium chloride, and we're going to say that's excess. All right, that's my answer. All right, hopefully that makes sense. Let's try one more for you to do on your own. So try this one on your own. I'm not going to show the work. I'm just going to give the answers at the end. Calculate the volume of carbon dioxide vapor formed when 92.88 grams of heptane, C7H16, and 55.76 grams of oxygen gas reacted STP, also remember. So if I have heptane, hydrocarbon plus oxygen, what kind of reaction is that? I could use the word burn, hopefully that helps. And carbon dioxide and the other product, balance it up, work it through. Ready? Answers? Pause it, try it. All right. So we're going to generate 35.48 liters of CO2, and we're going to have 70.25 grams of C7H16 excess. That means that my oxygen there is my limiting reactant. All right. Hopefully not too bad. Take care. God bless.